All right, so in 3.5, we're going to separate this into 2 days. Day one, we're going to solve exponential equations, and then day two, we're going to solve some log equations. So let's look at this first question. 20 times 1/2 to the x over 3 equals 5. And we got to solve for x. And so that's a very hard question to do. And so what we can do is we can kind of remember this property. It's pretty simple. So equal sign just means the two sides are equal, right? And if you look at this equation here, you can see that um, both of them are exponential functions. And what's also interesting is that both of them have base of b. And so if the bases are the same, then this equal sign tells you that the two sides are exactly the same. So then the exponents must equal. That's kind of, very simple uh, explanation. So let's say 2 to the second is equal to 2 to the x. The question says, what is x? Well, it's got to be 2, right? Because the two sides are the same, 2's are the same, and so these two must, by logic, have to equal. And so when you solve questions like this, what you can do is just try to make the two bases the same on the left and right of the equal sign, and then just make the exponents equal. Well, this is kind of hard to do, so what we're going to do is just kind of simplify one thing at a time. This is something times an exponential, so what we're going to do is divide out that something. So we're going to divide by 20 just to get rid of it. And remember, order of operation is very important here. So we don't want to do something against what we would usually do to solve equations. Okay, 5 over 20 reduces to 1 over 4. So you look at the left-hand side and right-hand side and you say, 1/2, 1/4. Is there any way that I can make them the same base? Yes, you can change that 1/4. 1/4 is 1/2 squared. So if I change that, then the two sides are exactly the same. Therefore, x over 3 must equal 2. And then that's an easy question to solve. X is equal to 6. So easy. So as long as you can make them the same base, it's a very easy question to solve. So let's go ahead and have you practice this. Let's pause the video and have you practice number 1. All right, the answer is a -4. Okay, go ahead and pause the video again and then try number 2. All right, when you get to this point, you might kind of feel like, I'm not sure how to do this, but I can see that this is 4 times 2. While 4 times 2 is nice, there is a 4 in there, but it's not going to equal to just a simple 4. There's an extra 2 here that we don't want. So this is not the way to do it. However, you want to think about 4 and 8 and then think to yourself, what other number could I change them both to so that they have the same base? Well, 4 is 2 squared. So if I change that 4 to a 2 squared, that would work. And then I still have the 2x left, so that 2x is still on the outside of that. 8 is 2 cubed. So then now I have the same base, but let's kind of talk about how to simplify that part. That is a power to a power, meaning an exponent to an exponent. So this is 2 to the 4x, which is equal to 2 cubed. And then now it's an easy question to solve. All right, what if the exponent cannot be changed to the same base? For example, this one, 3 to the b equals 17. Well, there is no way to change 17 to have a base of 3. So how do we solve b? Well, we got to get rid of that 3 somehow, right? And then kind of like before when we talked about exponent, if we want to get rid of an exponent, we have to use log of the same base, which would require log base 3, but we still don't know how to solve log base 3. So here is a trick. What we can do is if we take log of both sides, like so, then the log rule says if you have a log of something to a power, that power can be moved to the front as a coefficient. So this becomes b log 3 equals log 7. I'm sorry, 17. And so now the only thing we really need to do to solve for b is get rid of this log 3. And then we can see that to do that, we divide by log 3. So b is equal to log 17 over log 3. And then we use our calculator to figure out what that number is. 2.5789. Let's talk about this question again. Can we solve this some other way? Yes. You don't have to use log. You can use natural log. But you have to use some kind of log. There's no way to solve it without any kind of log. So same thing, move that to the front. Solve for b. All right, use the calculator. It should give you the same number, but you want to just kind of try it to convince yourself. 2.5789. All right, so let's do one more and then you can do some practice. So we have this question. Again, we're solving for x. That means we got to get rid of things that's far from x. Notice here we have a 2e to 2x. This is can be confusing for a lot of people. This 2x is only the exponent for e, not not the entire 2e. So how can you tell the difference? Well, 2e to the 2x and is written this way. 2e to the 2x is written this way. So you see the difference? This is an exponent for this entire base. This is the exponent for just this base. So kind of know the difference. Therefore, this 2 is multiplied to this e and it's not connected. And so if you want to solve this problem, the first thing is you got to divide by 2. Okay, you cannot divide by 2e. You cannot do log because it's not stuck together. Okay, so 3 over 2. All right, now let's talk about how to solve this problem. We know that if we want to bring that 2x down, we need some kind of log. But the interesting thing is this e. This e has a log with that same base, and that's log is natural log. And so we know that if there's a natural log and an e, that entire thing just cancels and we avoid the whole problem with having to bring the exponent as a coefficient to the front and all that stuff. This is just gone. So this is just 2x equals natural log 3/2. So now that's a very easy problem to solve. We're going to divide by 2 on both sides. One way to write this is divide by 2 means times 1/2. So if this helps you write in the calculator better. If you don't like to do it this way, that's totally fine. Just make sure when you put it in the calculator, you put natural log, parentheses, 3 divide by 2, close it, and then divide by 2. All right, so either way, let's go ahead and figure out the answer. 0.2027. All right, let's go ahead and have you solve these for practice. So let's have you try number 1. Pause the video, try number 1, come back and check it. All right, let's make sure that you're doing the right thing. So when you get to this point, it doesn't really matter which log you use. You have to use some log. The problem is actually bring down this exponent. When you bring down the exponent, you're bringing down the entire exponent, and you gotta put that in parentheses. If you don't put it in parentheses, you're going to forget that this natural log is distributed to both. So make sure that's in parentheses. Okay, now think about how you're going to solve for n. Remember, you're going to get rid of things that's farthest from n. So I'm going to give you a hint. That is this part and then this part. Okay, do not distribute first. When you distribute, you make this natural log 9 twice the problem. So get rid of it first. Okay? All right, go ahead and solve this problem and then come back and check the answer. All right, this is the answer, the final answer. Double check to see if you got it right. All right, so let's have you try this one. So remember, this one has a special base, e, so you want to pick the correct log to get rid of that base. All right, go ahead and check your answer.